Okay, in question number 7, I give you 3 infinite series and ask you some questions about them. The first question I ask is, does the series converge to a sum? Yes or no? Explain how you know. Well, some of you attempted to answer the question without actually exploring the series first. The very first thing you should do is generate a few terms of the sequence. So notice in the first sequence, or series, you start with n equals 1, and here's the formula, and it goes to infinity, so obviously you're not going to list all of the terms. But when n is 1, then this would be negative 2 to the to the 0, which is 1. When n equals 2, this would be negative 2 to the 2 minus 1 to the first, which is negative 2. When n equals 3, this would be negative 2 squared, which would be 4. And then n equals 4 would be negative 2 to the third, which would be negative 8. So you see we have a geometric sequence. We're multiplying by negative 2 each time, and it's getting bigger. So r equals negative 2. The second series starts with k equals 0. So your first term is when k is equal to 0. So I do 400 times negative 0.8 to the 0, which is just 400 times 1. So my first term is 400. Then when k is equal to 1, it's 400 times negative 0.8 to the first. Negative 0.8 times 400 is negative 320. When k equals 2, it's 400 times negative 0.8 to the second. In other words, I'm just multiplying it by negative 0.8 again. That's going to be a positive term. That turns out to be positive 256. And if you do k equals 3, 400 times negative 0.8 to the third, you end up with negative 204.8. So you see we have a geometric sequence again where you're multiplying by r equals negative 0.8 each time, and it's just going positive, negative, but the terms are getting smaller. So here the terms are getting bigger, here the terms are getting smaller. Here r is greater than 1, actually not greater than 1, but the absolute value of r is greater than 1. Here the absolute value of r is less than 1. The fourth sequence, you start with j equals 0, so when j equals 0, it would be 400 minus 5 times 0, which is just 400. When j is 1, it would be 400 minus 5 times 1, which would be 395. When j equals 2, it would be 400 minus 5 times 2, so minus 10, so 390, and so forth. When j equals 3, then I subtract another 5, 400 minus 5 times 3, which would be 385. So you see what's happening each time is I'm subtracting 5 each time. So minus 5, minus 5, minus 5. This isn't geometric, this is arithmetic. So this is arithmetic, and d is equal to negative 5. The first two are geometric. Now, it asks you the question, does the series converge to a sum? Okay, that means if I were to add an infinite number of terms, can I get a sum? There's either two things that happen when you add an infinite number of terms. Either it goes to infinity, or it doesn't go to infinity, okay? It's going to converge to something. It's going to level off to something. So here we keep adding, this will be plus 16, minus 32, plus 64. It's just going to keep getting bigger. It's going to fluctuate up and down, negative, positive, but it's getting bigger, okay? It's getting bigger. So I would say no, there is no infinite series. It goes to infinity because the absolute value of r is greater than 1. Okay, so you cannot find an infinite sum. Now the second one, notice I'm going positive, negative, but the terms are getting a little bit smaller each time. If I were to raise negative 0.8 to a really large power, it becomes a very small number. And so eventually, if I go a long time on the sequence, I'll get down to the point where my terms are getting closer and closer to 0. So when I add an infinite number of them, the sum is going to level off to something. So yes, it converges. I haven't said what it converges to yet, but it converges because the absolute value of r is less than 1. Now when we get to the fourth one, the answer is no. It's arithmetic. Arithmetic never converges to a sum. Now some of you may be looking at this sequence and thinking, well, it's getting smaller and smaller. I'm adding increasingly smaller terms, but let's think what happens. If I keep subtracting 5, eventually I'll get down to 0. And then it will be negative 5, negative 10, negative 15, negative 20. If it goes to infinity, I'm going to have an infinitely large negative number for the sum. So it does not converge to a sum. No arithmetic sequence converges to a sum. So question B then asks, it was a badly worded question. What I meant to say was, find the sum of the series that converges. So if any of these series converges, then find its sum. So let's look at series number 2. Series number 2 does converge, so I look at the way I find the sum is that S has to equal A sub 1 over 1 minus R. Recall that in the sum formula, I'm going to extend the page down here just a little bit, that remember we had S sub n is A sub 1 times 1 minus R to the n over 1 minus R. That was the sum of a geometric series. But if R is less than 1 and n is extremely big, R to the n gets very close to 0. So the whole numerator just becomes A sub 1 when we're dealing with an infinite sum that converges. So this would be 400. Let me get back to my red, it's easier to see. 400 divided by 1 minus a negative 0.8, which is 400 over 1.8. It turns out to be 222.2 repeating. That is the sum. And I think that's like 2,000 over 9, maybe, or maybe 2,000 over 9. I think that's right. Anyway, there's some fraction also that equals that. I forget which one it was. Okay, let's just take a look at the challenge problem as well. Some of you had questions about the challenge problem. Actually, no. I'm going to save that for the next video.